This video, we are going to talk about problems from 8.4. These problems will be like number 7, 9, and 11. And I have copied the problems that I'm going to be working over here to the whiteboard so that you can see the figures and I can draw on top of them. So first we want to determine the volume of this three-dimensional box. All the sides are in centimeters, so volume equals length times width times height is going to be 11 centimeters times 4 centimeters times 1 centimeter is going to be 44 cubic centimeters. So 44 cubic centimeters since it's volume. Next thing we want is surface area. And that formula is going to be 2 times the length times the width plus 2 times the width times the height plus 2 times the length times the height, 2 of each side of the box, basically. So there's 2 of these. There's a bottom and top, and there's 2 of the, there's the left and the right, and there's the front and the back. So this is 2 times 11 times 4 plus 2 times 4 times 1 plus 2 times 11 times 1 is going to be 22 times 4 is going to be 88 plus 8 plus 22 is going to be 118. And this is going to be area, so this is going to be square centimeters. That's what surface area is the amount of material that it would take to make the outside of the box. The volume is the amount of stuff that would fit inside the box. All right, now we've got a cylinder. And let's go ahead and get rid of this problem. Scroll on down here. The volume and the surface area of that right circular cylinder. And the volume is going to be pi r squared h. R is 5 inches and h is 13 inches. So 5 inches squared times 13 inches. You're going to need your scientific calculator for this to approximate to the nearest hundredth. So we have pi times 5 squared times 13, and we get 1021.02. And then this is going to be cubic inches. Cubic inches. Now the surface area, you probably don't know this formula off the top of your head, but it's 2 pi r h plus 2 pi r r squared. What is it doing? Right? And so the 2 pi r is the circumference. If I would slit the cut the cylinder down and open it up, it would have a length of 2 pi r, the circumference, times the h. That would be that rectangular piece if I opened it up, and then I've got two circles on the top and bottom. That's where the surface area comes from. So again, use your calculator here, and we're going to approximate. R is 5 and H is 13. So 2 pi times 5 times 13 plus 2 pi times 5 squared is 2 pi times 5 times 13 plus 2 pi times 5 squared is about 565.49, and this is going to be square inches. Right. One more here. And this is, let's go ahead and get rid of this one. Now we're going to look at this circular cone. So this is like an ice cream cone, but it's going to be closed at the top. Okay, so the volume of this cone is going to be 1/3 pi r squared h. It's a third of if that was a cylinder. And so this is going to be 1/3 pi. R is 7 centimeters and h is 2 centimeters. This is 1/3. Then this is 49. And this is 2. So let's approximate that using our calculator. Pi times 49 times 2, and then that divided by 3. It's going to be 102.63 cubic centimeters for the volume. And then the surface area is going to be kind of a crazy looking formula here. It is pi r squared, which makes sense. That's the circle part. But the other part is pi r times the square root of r squared plus h squared. And that has to do with there being a right triangle here in the Pythagorean theorem, that this is r squared and h squared. The square root of that is going to give me this side over here. That's going to be 49 pi plus 7 pi times the square root of 49 plus 4. 49 pi plus 7 root 53 pi. And we're going to stick that into our calculator. So pi times 49 plus 7 times the square root of 53. Close off, close that, and I get 314.04. And this is going to be square centimeters. This was cubic, and this is square. So that's it for this video. Next time we'll come back and solve an application problem involving volume and surface area. And that'll be our last geometry video. We'll come back and start talking about something else after that. So see you for the next video.